Hello everyone, I am P. Mohammed. In this session, I want to solve an interesting problem for you. Imagine you want to build a mirror which is like this. Imagine this is a mirror. This is rotated actually around this axis. This mirror is rotated, and we want this mirror to act like this. If we have an identifying point, we know this distance. If we put a light here, the light beams go and reflect parallel to the axis. And you can think differently. If we have a light here, the light beams come and reflect from the mirror and all of them collect in these points. Actually, some antennas that we use for our phones or television or satellites in the space use are like this. This is actually the antenna. Okay, and it has some receiver here. This is actually a receiver. The waves come and reflect from the antenna's body and collect all of them here, and we can actually extract the signals to our television, to our computer or our phone, and we can send them from space into the earth, something like that. Now we want to find an equation for this curve. What is this curve with these properties? Okay, let's draw actually something suitable. We should be good at painting. This is the mirror. We put it in our axis, this y-axis and this x-axis. Okay, consider one point on this curve, point x and y. Okay, what is this angle? This angle is theta. And now we know that tangent of theta is actually the slope of this line, and the slope of this line is y divided by x2. This is y and this is x. Okay, so we have this till now. Let's draw a tangent line on the mirror. The tangent line comes here. This angle, we name it alpha. You know how does the light beam act? Actually, this is a light beam. Okay, this point is the same point that we put the light, the identified point. This is the light beam. It reflects from the mirror parallel to this axis. These lines are parallel, and you know that if this angle is, for example, beta, this angle should be theta too. This is the actually method of reflecting of a light beam. Okay, and we have some laws in geometry. This is the parallel, this is the tangent line on tangent to the actual mirror. And this line actually collects two parallel. We have a statement in geometry that is two lines are parallel and a third line collects both of them. This line actually collects this line and this line, which are parallel, and so the angles are equal. Okay, so if this is alpha, this is alpha 2, because these two lines are parallel and this line, the tangent line, collects both of them, and this is alpha and this is alpha. And we said that the light beam acts in such a way that these two angles are equal, so this is alpha and this is alpha. Okay, and we know from geometry too that when this is a triangular, this is a triangular, and this is actually pi minus this angle plus theta equals pi, and also this angle plus this equals pi 2. And if you actually think about it, theta equals to this angle plus this angle, so it is equal to 2 alpha. We have this, we have something else. Actually, this is the tangent line. The tangent line has a slope, and slope is derivative of y with respect to x in that point. So this is the tangent line. From one aspect, its slope is tangent of alpha, because this line is horizontal and this angle, tangent of this angle, means the slope of the line. So tangent alpha, which is the slope of this line, is equal to derivative of y with respect to x in this point, because the derivative means the slope of tangent lines on the curve in each point. So this is dy divided by dx, and we have this relation too. So for solving the equation of the curve, we should consider these relations. I write them. Tangent of theta is equal to y divided by x, and theta is equal to 2 alpha, so I write it here, equals to tangent of 2 alpha equal to y divided by x. Okay, and tangent of 2 alpha is this, 2 tangent of alpha divided by 1 minus tangent squared of alpha, and this yet is equal to y divided by x. And we have tangent of alpha here. It is dy divided by dx. Actually, it is y prime. So 2y prime divided by 1 minus y prime squared is equal to y divided by x. This is, what is this? This is a differential equation, and we are going to solve this differential equation. Here 2y prime is equal to y on x minus y on x y prime squared. This is y. And so y on x y prime squared plus 2y prime minus y on x equals 0. And so you can actually take y prime pure. Y prime will be equal to minus 2 plus and minus radical 4 plus 4 y on x to the power of 2 divided by 2y divided by x, and y prime will be minus 1 plus radical 1 plus y on x squared divided by y on x. So now we have y on x here and here. We should name it something new like z. We name z as y on x and we replace it. But if we replace this by z, we should replace y prime too. So get rid of y and do the rest of the computations with z and x, and forget about y for now. Here y is zx, and so y prime is z plus x z prime. So do these two replacements here. So z plus x z prime is minus 1 plus radical. Actually there is a minus, but we do first for the plus sign. But let's keep it. It's not important. So we have this. Okay, let's actually put the z sentences on one side and x sentences on the other side. So x dz dx is equal to minus 1 plus minus radical 1 plus z squared on z minus z. So dz on this is just by z. Put this in the actually under dz, okay, and this will be 1z here and minus 1 plus z squared plus minus radical 1 plus z squared is equal to the x on x. This has a beautiful shape. Okay, now you can do the integral. So integral of z dz divided by plus minus radical 1 plus z squared minus 1 plus z squared is equal to, integral of this is simple, it is ln of x. Let's name u radical 1 plus z squared. When we replace this by u, we need to replace this dz with u2. So z is equal to radical u squared minus 1, and so dz will be u on radical this, which is z. Okay, now do the replacement. So ln of x is equal to integral of z dz. What is dz? Dz is this. Dz is u on z, which these z's cancel each other, on this plus minus this is u minus u squared. And if you cancel a u from each other, from both ones, so ln of x is equal to integral, here we have a du. Okay, I'm sorry, you have ln x equal to integral of du on plus minus 1 minus u. The answer doesn't actually relate to these signs. The answer is an ln. So ln of x is equal to actually ln of plus minus 1 minus u, but we need a minus here because the derivative of this is minus 1 and we need a minus 1 here. If you're lost, you can just forget this, forget this, forget this. Actually, these were calculations and not important. Okay, this was our equation and this is the answer. But we have to, of course, we have to clean the equation and make it more beautiful. So x is this to the power of minus 1, mean plus minus 1 minus u. What was u? U was plus minus 1 minus u. What was u? Oh my god, these are papers, but we can remember u. I can remember u, radical 1 plus z squared, and is equal to, and what was z? It was y on x, the whole squared. This is x. And if you actually do some mathematics, you can actually multiply these two. So 1 is equal to plus minus x minus radical x squared plus y squared. And what is this? So 1 plus minus x squared is equal to x squared plus y squared, and so x squared plus minus 2x plus 1 is equal to x squared plus y squared, which these cancel each other, and so y squared is equal to plus minus 2x plus 1. This is the answer. What is this? Remember, this is the answer of this curve, but this curve is rotated in the 3-dimensional space. So you should rotate this. At first, let's actually convince ourselves that what it is. This is parabola. Okay, this is a parabola. This is horizontal if it was actually here like this. Vertical, it had x squared and y, but now that is horizontal, it has y squared and x. Okay, so parabola has the interesting property that is used to antennas and lights like this. And another interesting problem is that if you have some water here and you rotate this actually around this axis, the water would have a shape. It would have a shape. Okay, what is this shape? This is parabola 2, and it is interesting. You can think on this problem, and next time, maybe another time, I will solve this problem for you too. Good luck. I am P. Mohammed. I hope you enjoy it, and don't forget to play the music. I am going to play my music after solving, and you go and play a good music for yourself. Good luck.